This conference will now be recorded.
Sir, I have a little doubt. Can I ask, so sir, can
Yeah,
you
please.
mention about the use cases for SD, SCD 1, 2, and 3? But like in which scenarios we will go for SCD 1, and which scenarios we will prefer SCD 2, and which scenarios we will prefer SCD 3? I think you mentioned, but can you just summarize?
Yeah, actually we have not started the training. Yeah, it will be covered today.
Okay. Okay.
Yeah, I just said, I mean, as a normal discussion, but yeah, I will cover it today. Okay, so yesterday we have seen about data warehouse. Okay, and what is data warehouse? What is the purpose of it? Yeah, those things. And we also discussed that data. Okay, before designing a data warehouse, yeah, there is a concept called data warehouse design. Okay, so yeah, there should be a design, right? Like how the data warehouse should be designed, like how the fact tables and dimension tables should be modeled. Okay, so as part of the design in a real time, there will be two things called star schema and Snowflake schema. Okay, so any company, either they'll be using either star schema or Snowflake schema in order to store the data in the data warehouse, and in order to design fact tables and dimension tables. So yesterday we have also seen what is fact table and what is dimension table. So I said that fact table means all the numerical values or measures. Actually, numerical values only is called measures, means number data is called fact data, or those tables are called fact tables. And dimension tables means textual or descriptive data is called dimension data. Means only theoretical or descriptive data is called dimension data. So it talks about brand, color. Okay, so features. For example, location name, region, state, country. This even pin code also will comes to dimension, because pin code is number, so it can be fact. No, it's not like that. Fact means counts, which is used in the representing the business, like counts, quantity, price, total price, average, all aggregate functions, right? Something max, count. What are the aggregate functions? Somnath, what are the aggregate functions?
Sum, count,
You
min,
said
max,
two, some,
max,
okay.
average.
Yeah, right. Sum, count, min, max, average. Okay, these five are called aggregate functions. So generally, these will be applied on the sales or quantity, okay, or revenue. So these things. So all these values will be comes under fact data. Okay, so yeah. Okay, so now we are good about, we know about fact data means fact table, because this data is stored in a table, so they are called fact table. And dimension data or dimension tables. Dimension means textual or descriptive data is called dimension data. That's all. If somebody asks what is dimension data, textual or descriptive data, or you can say descriptive data. Textual or descriptive data is called dimension data, and measures, numerical values or measures is called fact data. Okay, so this descriptive data is always talks about fact data only, because in fact table you will have only numbers, but how that can be described using dimension tables. So okay, I will show you how star schema and Snowflake schema will look like. Yeah, see here. So this is an example of star schema. Star means, for example, fact table. So actually, I will tell you what is star schema. Okay, this is a definition. What is a star schema means? A fact table surrounded by denormalized dimension table. This is very important. Fact table surrounded by denormalized dimension tables is called star schema. Fact table surrounded by denormalized dimension tables is called star schema. So what do you mean by denormalized? Denormalized means, I think Somnath, what is your qualification? I mean, which degree you studied? Computer science or MCA?
No, I did triple E, electrical and
What is that?
electrical and electronics. I did BTech.
Okay, so okay, you may not have an idea about what is normalization and all, right?
Yeah, not good idea.
Okay, or you heard about it? Normalization?
Heard about it.
Okay, cool. So yeah, what is normalization means? For example, we can have a table with 100 columns. Okay, for example, I will tell you customer ID, customer name, email address, street. See here, street, city, state, country. Okay, and all those things. I can have. You see, Can you see my cursor?
Yes.
Yes.
Yeah. So I can have a customer. You see, customer ID, customer name, email address, phone number, customer street, city, province, okay, country, region, everything in one table. For example, customers means, it can be millions of records. You see, all the people, every person is a customer, right? So customers are like millions and billions. So in every record, street, city, state, region will repeat. For example, region means what? Asia Pacific, yeah, something like Asia, right? Asia, APAC, and US region. I think hardly some 4 or 5 regions is there. Entire all world is considered. Okay, so and similarly state. India is one country. Similarly, take country. Okay, India is one country. So in India, how many customers are there? Let's say 100 million. So in every record, India will be repeated. Yes or no? If you put them in one table.
Yes.
This point you understand?
Yes.
Yeah. What about Prasad?
Sorry, sir, not understanding.
Yeah. What I said is, if we have to write an Excel sheet, Excel sheet means you consider it as a table. Okay, table means rows and columns, right? So yeah. So yeah. Okay. In the customer ID, this CX means customer ID, customer name, region, city. Okay, date. Yeah, this region. Okay. So what I'm saying is, this is a table. Table means rows and columns. Yeah, all the data will be stored like this. See, customer IDs will have unique ID for every customer. Okay, customer ID 1, 2, 3, like that. 1 million records will be there here. All are unique. 1 million. So you consider them as unique. Okay, customer ID will be unique. But you see, 100 million people are there. Okay, in India. But for them, okay, this is region, city. Let's say there is a column called country. But for all the people, it will come as in India only, right? For all 100 million people. This is what I'm saying. It will come as India or no? For all people of India. Prasad.
Yes, yes, sir.
For all the Indian people, country will come as India or no?
Yes, sir. India.
Yeah. Yeah. Similarly, if India has 100 million records, for all the 100 million people, country will come as in India.
India.
Okay. And for the next 101 million, okay, if they are American US people, let's say, for them, country will come as US. And the next, let's say, some 200 million and one. If they are from UK, then country will come as UK. Here, my point is, it will have a duplicate data here. You see, India will be there common for all 100 million people. This is called
Yes.
redundancy, and this is called denormalization. Denormalization means all the data will be present in single table.
Okay.
Okay,
Okay.
region, city, state, country. For example, state AP. Let's say you take AP, or I think you take UP. Okay,
Okay.
UP, Uttar Pradesh. Okay. So for let's say out of 100 million, 10 million people are from UP. Then for all those 10 million people, the state will come as UP. That means 10 million records have the same value UP out of 100 million records of India. So for country, yes, all 100 millions will have India. For UP, since 10 million people are there, so all 10 million records will come as UP. Similarly, for AP, let's say that is 10 more million. Then another 10 million records will be AP. So my point is, because of having all the columns in single table, there will be redundancy in the data. That is the point. Redundancy means duplicate values.
Yes.
You understand?
Yes. Yes.
Yeah. So Somnath, you are also clear, right?
Yes.
Yeah. So this is called denormalized, means which is not normalized. All the columns will be there in a single table. So when we put all the data in single table, like you see, have mentioning columns, it lead to, of course, it will have redundant data. Redundant data. Only customer ID is unique. Okay. Maybe customer name may be unique, but yeah, sometimes names may match, but that is fine. But especially region, you take only 5 values will be there in region, RCFS speak, EMEA, EU, something like, or some 5-6 values there. But all these 5-6 values only will repeat throughout all the world population. How much? Only India population is 100 million. Let's say world population is some 2 billion. All the 2 billion records, only these 5 values only will repeat. That is called redundancy. And similarly, country, all 100 million people of India will have India as their country. So India will repeat 100 million times. And similarly, if America, let's say it has some 50 million people, then all 50 million records will have US as their country. Okay. So, and similarly, let is the state. Let's say UP has some 10 million records. All 10 million records will have UP as the state. So this is called redundancy. Redundancy means duplication of the data. If we have the data in denormalized form, denormalized means the data present in the same table. All columns will put together. So, okay. So what is the issue with the denormalized means? You will have more redundant data. But let's say you divided this into customer and location. So in location table, you can have something like location ID. Okay, location ID. Generally, it is pin code. Okay, location ID means it's the pin. Okay, so a location ID, of course, again you can have street, city, something like state and region. So then how many you will have? Let's say in the original table customer ID has 2 billion, means 2000 million. Generally this location table will have hardly some, maybe some 1000, 2000, some 5000 records will be there, because how many, for example, forget about this, street will be covered under address. Okay, so location or pin. Okay, so city, state, region. Of course you can add country also, country and region. So in the whole world, we are talking about world. Okay, so how many, all the data here, there is not much redundancy in the, if you mention region in the customer table 2 billion times, every value is repeated, state, country and region and all. But here how many pins are there? That many times only they are repeated. Okay, so that means here we are avoiding the redundancy. For example, you have 535,001 or 5,01,000, let's say. So in, for example, in entire India you have some 5 lakh pin codes. Okay, so the region will repeat only 5 lakh times. Of course, country, because India, you see, INDA, India will belong to same region. Entire India will become to same region, that is APAC, Asia Pacific. Okay, yeah, state, how many you will have? Something like some 34 times it will come, or these 34 values only will repeat. So basically, the location table will reduce the redundancy. Redundancy means duplicate values. The same region is repeating 2000 million times if it is there in customer table. Okay, because customer is 200 million, 2000 million mean 2 billion, 2 billion. So basically every value has to be repeated 2 billion times. But if you divide this state or region or location as a separate table or entity, then you will reduce the redundancy. You will reduce the redundancy. Okay, so redundancy means duplicate values. So like that, what, so how we are avoiding the redundancy is by splitting the table. By splitting the table is called normalization. What is normalization? Means dividing the larger table into smaller tables to avoid the redundancy is called normalization. You understand what is normalization? Normalization means dividing the larger table into smaller tables to avoid the redundancy or to reduce the redundancy is called normalization. Means in normalization, a big table will be divided into 2 or more tables. You are clear now?
Yes.
Yes.
Yeah. Okay. So now, for example, I have divided this customer table into, okay, customer ID, customer name, okay, so customer email, and okay, I mean customer ID, customer name into what table? Is the city, okay, state, all those things into another table. Then how do you join these two tables? For example, you want to know customer is there in which state and all. At that time, you have to join these two tables, right? To know customer will belongs to which state and which country or which city. Because now customer table is different. Okay, this his location table is different. Okay, here location ID is there, right? So at that time, what we do is, here we will put location ID, one common column, so that we will be able to join based on the location ID. For example, I'll mention here. Yeah, so this is the customer table, okay? Customer location ID. Like this, I will divide this table. So what I'll do is, in order, you see, this table has only customer data, okay? So this table will have only location details. But if I want to know customer, because generally in the report we want customer along with the, I mean, his city, state, and country, right? So at that time we join these two using a common column. So that is the reason in the tables we maintain the common column. For example, employee department table, you see in employee table you have employee ID, employee name, department number, salary, hire date, and all. And in department table you will have department number, department name, location. So what is the common column in these two tables? Department number. So that we can join these two tables. In employee table, you don't know what is the department name and department location. You can get department name and department location only by joining these two tables. Similarly, in customer table, you don't have customer state and city and country. Okay, but only in location table only you have it. So if you want customer state, city, region, and all, you have to join these two tables. So in order to join, you will be maintaining one common column, you know, something like location ID. So if you join this, wherever this location ID matches, it will bring the respective, you know, his region, his city, his country, and his state values. You will get it. You understand how joins will work?
Yes, sir.
Okay. I think Somnath, you already aware of it, right? I mean, at least
Yes.
by, yeah. So that is the reason we maintain common column in order to establish relationship. That's why we mentioned it as primary key, foreign key. So in customer table, actually customer ID is the primary key. You see this A, column A in Excel. Okay, and location
is
ID.
important, sir.
Yeah,
Location ID
right.
in
Yeah,
location table, location ID is the primary key.
yes. Yeah, that's all. Okay. So in that way, we will use this common columns for the join purpose. Okay, cool. So here the thing is, what is normalization? Normalization means splitting the larger table into smaller tables to avoid the redundancy is called normalization. Okay, so this is not mentioned in this document, but yeah, you can just remember or write down somewhere. What is normalization? Normalization means splitting the larger table into smaller tables to avoid the redundancy is called normalization. What is redundancy? Redundancy means duplicate data is called redundancy. Okay, then what is star schema? Fact table surrounded by denormalized dimension tables is called star schema. What? Fact table surrounded by denormalized is very important. Denormalized means data is not normalized, it is denormalized. Okay, so that is star schema. Okay, then what is Snowflake schema? In Snowflake schema, fact table surrounded by normalized dimension tables. Normalized means dimension tables are further divided into two or more tables. That is called normalized. Normalized means a table is further divided. Which table? The dimension table only. The dimension tables are further divided into smaller columns or less number of columns to avoid redundancy. That is called Snowflake schema. A fact table surrounded by normalized dimension tables is called Snowflake schema. Fact table surrounded by denormalized star schema. I mean, you need to remember this. You should not get confused. Denormalized dimension. Denormalized means they are not further divided. Denormalized. That is star schema. Factorial surrounded by normalized. Normalized means dimension tables are further divided. Normalization means dividing big table into small tables. That is called Snowflake schema. So star schema means, for example, you see fact table will be there, and it will followed by surrounded by dimension table. You see this formed like a star. That's why it is called star schema. See, this is appearing like a star. That's why it is named as star schema. So in star schema, what happened? Fact table will be there, and it is surrounded by dimension tables. So that is a star schema. So what is Snowflake schema? Sorry.
It is not denormalized dimension in the picture.
Sorry, I did not get you. Means so you are saying that everything should be included in one table?
No, I was thinking item like location key will be present in the time table. Is it?
Okay, now along with all other tables, right?
Yeah, like location key column should be present in a time table. Like branch key also should be present. Is it like that?
No, actually, yeah. So yeah, I mean, actually, that is actually concept of denormalization and normalization. They just further refined it to have a specific dimension for representing time, location, and like that. For example, you see, for location, they kept everything: location key, street, state, province or region, country, like. So it will be further divided. This is called actually location dimension. This is actually location. It will have all information about the location. Okay, it will not be mixed with customer or anything. Similarly, for time will have time key, means that is the primary key for day of the week, month, quarter, so everything. But this can be again further divided in the normalized, in the Snowflake schema. If you want to divide it, we can divide it further. But this is the time dimension. It will have all the information about the time. So that's what. Otherwise, we will say that everything should be there in the customer table only. All item, location, branch, time, everything. I mean, that will make a mess out of it, right? Then we will have only one table. You got it, right? Then we will have only one table, and there is no particular pattern or anything. For everything you will have only one table, but there the data will be it is messy actually. So what they did, I mean, actually the architect is the design, right? So they did it for everything one dimension. For time, yes, there is a time dimension. Actually, sometimes in the entry they'll ask, can you please tell me any dimension tables? You can tell. Okay, for date or time we call it as date dimension, or you can also say time dimension, or you can say date dimension. Okay, it will have day of the week, okay, or month means actually it is day of the month, and quarter, year. So all the values related to date will be there. Similarly for location key, street, state, city, country, region will be there in this. So in Snowflake, what happens is they will be further divided. I will show you that diagram. But yeah, these are the denormalized dimensions for respective area. For example, area means here, yeah, category, location. For location, yeah, these are the dimensions. For time, this is the dimension. These location and time are common. Remaining will vary from business to business. For example, in case of retail market, we call it as item key, item name, brand type, supplier type, and all. And in case of branches, yeah, it is multi-region business, then branch key, branch name, type, and yeah, these things. But yeah, these are the dimension which are common in both star schema and Snowflake. I mean, that is the at the highest level dimension. But my thing is, they will be further divided in case of Snowflake schema. Okay, but you see, if we mix them with in fact, customer is again another dimension. Okay, customer ID, customer name, those things, customer email address, phone number. But if you want to club, you can club, but that will, as I said, it will be 100 million records, right? So what they did is, customer is again a dimension, and reason is again dimension, but on a high level, yes, they are all dimensions. Okay, I mean, we segregated customers as a different dimension because it will have only customer related information.
Okay.
Otherwise, it all will make messy, right? These are high level dimensions. Okay, for example, you see, I will show what does it mean by denormalized. Yeah, this is denormalized. Means hierarchy will be there. Again, in region, it will be again further divided. In country, again further divided into cities. So that means same when one region, one dimension, you are dividing further. Like this: region, country, city, office, year, quarter, month, week, day. So if you want to divide dimension into further, then it will become a Snowflake schema. Otherwise, yes, we will maintain separate dimension for date and time, or date or time, and location, and of course item if it is a business is related to some stores or something. Yeah, even for I mean, multi business, yeah, branches and all. But yeah, this is the high level dimensions which we should consider. Okay, if you want to divide further, then it will become a Snowflake schema. Somnath, you understood, right?
Yeah, yes, sir.
Yeah. So, but as I mentioned here, if we put everything in one, actually it will be a messy. Okay, because these clearly two different entities. Okay, entities means you can say categories or tables: customer and location. Customer will have only customer data because that's a meaningful entity. But if you club everything, what is the use? All dimensions you can have only one. So I mean, actually that will not give us. I mean, first thing is that everything will be clubbed and it is a messy. So because in the design we want to make everything clear, so customer will be considered as a separate dimension, customer dimension. Especially if we are dealing with banks or even anywhere, customer dimension will be there because every person is a customer. So customer ID, customer name, his email address, phone number, address, these things will be there. And similarly, location is a separate entity. Okay, so yeah, this example I gave you just to explain what does it mean by normalization and denormalization, so that it can be easily understood. Got it, Somnath?
Yeah. So because in this example you gave location ID in both places, no? So I thought it should be present in both the dimensions. So that's why I
No,
asked.
yeah, right. But you see, now I'm coming to that point. So now you see the fact table will have the IDs of all the dimension tables. See here, time key is there, item key is there, location key will be there, and branch key will be there. So yeah, this is the fact table is relation or linked with the dimension tables. For example, you see fact table will have all the keys, time key, okay, which will join with the time dimension. And if you want to get the day or week or month, quarter, year, means for example a particular transaction happened, if say fact table will be joined with time table, and it will get it what day it happened, and in which week it happened, and in which month it happened, and which quarter it happened, and which year it happened. You can get any of the data by joining. Similarly, item key, if fact table will be joined with item table based on item key. Item key is the, it is the primary key in item table, and all the keys of the dimension table will be present in the star schema. I mean, in the fact table. That is actually, that actually I want to say while I talking with fact table. Fact table will have all the keys of the dimension tables. For example, you have customer dimension here, then it will have customer ID also in this fact table somewhere down. Because otherwise, how do we join fact table with the dimension table? So fact table will have all the keys of the dimension tables in this. Only keys, nothing else. Nothing else means, yeah, others are like measures. It will have measures means like items sold, okay, or total amount, or total sale, or average sales. These are called measures actually. Okay, like item price. So based on item price, yes, we can calculate total sale. And of course, you can, once you have item price and quantity sold, those details, definitely you can, for example, you can join with item table and join like, you know, item name, particular item, how many items sold or how much amount is sold. Or for example, you can join with location and city wise sales, you can write a query, because fact table will have number of items sold, okay, for each item. And if you join with location, city wise you can get it, or state wise you can get it. Or if you, for example, if you join with branch, you can get branch wise sales. Okay, so that is the reason every dimension table will have, yeah, of course, every table will have its own primary keys and all those keys will be mentioned in the fact table. Why? Because if you want to get a meaningful report, we need to join them with these dimension tables, and all the facts will be mentioned in the fact table. What are those facts? Item price, quantity sold, these things. Yeah, if these things are there, then based on that you can calculate anything. Item price means what is the price of each item. Quantity sold, how many items sold. Then obviously if 10 items are sold and you know price of each item, you can know, right? For example, item price is 10 rupees and quantity sold are some 10. Then 10 into 10, 100 is the total amount sold. So like that. So those measures will be stored in the fact table, like item price, quantity sold. Okay, so if you want to know in a day how much sales, you will join with the time dimension, and for entire day you will get total sale amount for entire day. Or if you want to get for entire month, if you join this time dimension with fact table and apply where month equals to January, then for all the records of the January means how many? The 31 days will be summed together, and you will get your total sale. If you want sale, or if you want number of items, total quantity sold, you will get it. Or if you want to get average, you will get average. Whatever it is, all the aggregate functions, min, max, average, sum, count, you can get anything based on the what type of dimension you are joining. If you're joining with branch, for example, you want to know branch wise monthly sales. Okay, then you have to join with branch based on branch key, and monthly means you have to join with time dimension, okay, with time key, then put filter on month, so you will get month wise, okay, all the branches total sales. Or if you want branch wise monthly sales in every state, then you have to join with location and apply filter based on state, or state, or street, or city, whatever, or country, whatever filter you want. So yeah, that is the reason every table will have a key, and that key will be part of the fact table. So that's why fact table will have two sections. One is key section. This is called key section. all these keys. Okay, see, time key, item key, branch key. Look, this is called key section. Key section means it will have only keys of all the dimension tables. And other section is called measure section. Measures means it will have only numerical values. What are those numerical values? Item price, quantity sold, these things. So if you have only those two, that's all, you can calculate anything, because number of items you know, and you know the price of each item. Then based on number of quantity sold, you can calculate anything. Item price, you know, for example, item price is 10 rupees and quantity sold is 20. Then 20 into 10, 200 rupees is the total selling amount. Or like that, you have another item sold, okay, that is 5 rupees, okay, and total quantity sold 500. Then 500 into 5, 2500. Then average, then these two will be averaged. So I mean, once you have item price and item quantity sold, you can do anything, total, sum, average, anything. And later on, you can write any query. If you want to branch wise, you can do branch wise. You can wise month wise, you can do month wise. You can do, I mean, city wise sales, you can do by joining with that respective dimension. How do you join with respective dimension? Based on the common column. Common column, because fact table will have that column in the fact table. Are you clear how facts and dimensions are linked? Both Prasad and Somnath?
Yes, sir. Yes, sir.
Yeah. So that is the reason the keys are part of the fact table. Because if you don't put the keys, you cannot join, right? So if you cannot join, then how do you get that report related to the dimension? So that is the reason. This is all designed actually, okay, by the data warehouse. I mean, when these concepts are invented in the when they are invented, yeah, this is the design. Fact table should have all the keys of the dimension tables. Bus. Why they should be? Because by joining them, we can get the respective information whatever we want. Okay, so these are the dimensions. Okay, and if you want to further divide or go in depth, okay, if you think that location is a big table, or item is, for example, you see item, especially in supermarket, so many items will be there. If you want further divide, of course you can divide based on supplier type, or you can further divide. Or for example, you are representing worldwide data, then the location table is too big, then you can even further divide. Okay, location, state, country, region, and yeah, state ID, you can have it another, okay, state, city, pin, street, like that. Because otherwise, if you divide based on city, there are so many cities throughout the world. Even in India, we'll have so many cities. So in that way, this dimension will become big. So if you want further divide, you can further divide. If you further divide, it will be like Snowflake schema. If you don't divide, okay, I think even if it has 10,000 records in location, or even 1 lakh record, that's fine. Means that's fine. Actually, in the real time, even 10,000, 20,000, 1 lakh, even 5 lakh also is not a big number actually. Okay. So generally, that is the reason the dimension tables are very small actually. Small means they hardly will have some 1 lakh, 2 lakh, 5 lakh records. So that record count is not much big in the production. Okay. So yeah. So all the things or all the measures will be there in the fact table. So, but for the reporting, what is required? You need to join this fact table with the dimension table to get your final report in a meaningful way. Okay, fine. So I mean, now the star schema means the star schema means fact table surrounded by dimension tables is called star schema. Okay, that and the dimension tables are denormalized, means they are not further divided. Let's say the time dimension and location dimension, they are further divided. Or let's say you see the item dimension is further divided. Yes, of course you can divide. Then what happens? For example, item will have item key, item name, brand. Okay, item key and supplier type. Okay, only these two. And again, supplier, you have, separate dimension. Okay, see, I'm telling item is divided into item key and supplier key. Okay, supplier key only I have it, let's say. And I have one more dimension here. Okay, let's say I have here. Okay, one more dimension with supplier. Okay, here I have a supplier dimension with supplier key, supplier name. Okay, and for generally, some suppliers will supply so many things, right? So like that, I have all the list. Then you have to join this item table with supplier, whatever I have divided here, to get the supplier level details. Similarly, this location, I have only location key and city ID. And I have one more dimension here with city ID, state ID, and region ID, and all other things. Then if you want to get state, country, region, you have to join this location table with this table, So you have to join location with this table, and then you have to join location with fact table to get whatever that location details. That means in Snowflake schema, you will have more joins. That is the point I want to establish. You got it? Because in Snowflake schema, the dimension tables are further divided. So if you want to get the data, you have to join this with other divided table, like whatever the new tables you split. You need to join with this, and then you join this with fact table to get whatever data you want. So that means in Snowflake schema, you will have more joins when compared to the star schema. That is the point I want to make.
I didn't understand one fact. Why we'll go for Snowflake schema? Like if we want to add supplier dimension, we can add directly into the star schema, right?
Yeah. Right. So yeah, why do we divide the dimension into sub dimensions? That is your point, right?
Yeah. Scenario.
Yeah, I will tell you. When do we go is, if you want to, that's what actually in real time, we want to do precise reporting. Precise reporting means I want to have my report. Okay, so wait. Yeah, this is called actually cube. Cube means 3D. 3D means, cube means, right? Cube. Height, length, and width, height. So 3D. So you want to do 3D reporting. Means, for example, you divided this item into supplier type. So then you can get your reporting done and whatever dimension you want. Okay, so in actually we call it a cube reporting. In cube reporting, what happens is you can have particular measures. See here, generally if we see in mass, this is x-axis, y-axis, and something like height will be there. Okay, something like this z-axis. So here in 3D reporting, you can do one on month, product, and region, like that. Or at the same time, you can analyze the data on multiple dimension wise. Okay, so if at the same time, if you want to represent your data on multiple dimensions, and that too with low granularity, at that time they will divide this into, this is one of the question that generally comes. What is better? Okay, I think I already have here. What is better, star schema? You see, star schema, Snowflake schema, which is better? That is actually one of the question that will be here. So okay, so I think it will be there somewhere. So we should never say that, this is what we should never say, that star schema is better, the Snowflake schema is better. Okay, So what you said is right. The same thing, whatever you can do is also can be done directly from the star schema. Okay, but why should we again further split? There are two reasons. Number one, okay, so if the dimension tables are too big, it makes sense, okay, to divide them, okay, into smaller, or in other words, why we are splitting? To reduce the redundancy. Redundancy means duplicate data. Okay, duplicate data. Let's say for example, this item table has 10 lakhs records. Okay. 10 lakhs records coming from some 100 suppliers. Hello, remember, I mean, listen carefully. Item table has 10 lakh records. Okay, means all the 10 lakhs records are coming from only 10 or 100 suppliers. Okay, only 100 suppliers will be normally less, right? For example, you see how many milk packets we have in my, for example, I'm in AP, some 10. I mean, we so many milk is sold, but they're all hardly from 4 or 5 suppliers. Something like Heritage, something like some Jersey, something. So suppliers will be less, but the number of things that they supply, like items, will be more. Okay, so totally they are supplying, let's say, 10 lakh items. So all those 10 lakh items, same, all these 5 or 10 or 100 suppliers will be repeated. Means supplier will be like causing to some redundancy. But if you have only item key and supplier, then this item table will have item key and supplier in one dimension, and supplier dimension, which I'm going to create here, will only that 10 100 suppliers. Okay, supplier key, supplier name, and all the products that he is supplying. Maybe each supplier is providing maybe some 100 or 10,000. Like I have 100 suppliers, right? 100, and each one is providing, maybe some people are supplying some 5 items or 10 items or 20 items. So only that much small data will be there in the supplier table. So if they want to, so my point here is to avoid the redundancy. Why we split the same thing in the normalize? Why do we normalize, or why do we split? First, number one is to avoid the redundancy. Otherwise, all the same, only 100 suppliers will be repeated throughout this 10 lakhs records of this item table. Suppliers are only 100, but they will be repeated throughout this table. This table has 10 lakh records. Then only the 100 suppliers will be repeated. So we will split it. Number one is to avoid the redundancy. Number two is, actually this is the main important reason. If we divide into supplier type, you can do the reporting on the supplier dimension also. Okay, you can do reporting directly from the supplier. Like you want to know, like, which supplier is actually making more profit, or which supplier is actually giving more business. That you can do if you have, like, this is granular. Granular means next level. You see, this is high level supplier type, but in the supplier you are again further dividing into supplier ID, supplier type, I mean supplier name, and now items supplied by each supplier. So that is the next level, means least granularity. So actually, why do we have Snowflake schema? Means if you want to do finer reporting, finer means at the bottommost reporting, then we will go for Snowflake schema actually. Okay, in Snowflake, number one advantage is we avoid the redundancy, means data duplication you are avoiding, so you will save the cost. You will save the cost. I mean, cost for storage, cost of the storage. Why? Because you are avoiding the redundancy. Number two, actually, this is main reason. You can do reporting at the whatever dimension you want, because you are splitting into item into supplier, so you can do reporting at the supplier level. For example, here the region is dividing into let's say city, then you can do reporting at the city level. But of course, can't we get this reporting at city level in the denormalize? You can get it, because anyway you are joining, right? here you are joining with location table, and here also you can get it. Here also you can get it. Okay, but yeah, the thing is that while all the data present in location, there will be some redundancy. Okay, so if you split it, some redundancy will be avoided, and
So why the supplier I need to split it on item? Like I can split supplier as a different dimension, and I can do the reporting on supplier also.
yeah, of course, you can supplier put as a different dimension, and you can put supplier also. Then you should put supplier key in fact table. I mean, in fact table, right?
Yes, yes, correct.
Yeah, you can do like that also. You can do like that also, but
So
at that
schema
time,
is generally not used, or is it used? Like there is some scenario which star schema will not able to do, and Snowflake will be able to do. Is there any scenario, sir?
no, there is no nothing like that. There is no nothing like which star schema cannot do and the Snowflake schema can do. Okay, there is nothing like that. Okay, so it is only segregation of the data.
Yeah, because if I do go for Snowflake, if I do have to go with the supplier dimension, I have to join two times. But in Star, I can get reporting on supplier with one join.
Yeah, right. Yeah, that's what. If you want, but supplier, but supplier you are saying, but supplier is providing which items? Then you also end up joining with item tables, right? Item dimension.
Yeah, so supplier, yeah, okay.
You got it right?
Hmm.
Yeah. So yeah, you can have only, I mean, instead of item, you can see it also supplier, and you can have a supplier ID and then again item key, item number. Or you can have a supplier as a separate dimension, and you can put supplier key and you can mention that supplier key in fact table. But still, if you want to know which items he is providing, you can join with item table. Or you can have only single item and you can mention all the item key and supplier details in this here itself in the single dimension. Got it right?
Yeah, okay.
Yeah. So I mean, that's why I was saying we should not. People will ask which is better, star schema and Snowflake schema. We should not answer star is better and Snowflake is better. Okay, both has their own. I mean, both has their own advantages. Only thing is that in star schema you will have little redundancy, but you will have less number of joins. Right? In star schema you are not going to join with further other dimension tables, so less number of joins, so your performance will be faster, but you will have a little redundancy. That's fine. Redundancy means duplicate data, so what happens, you will only lose some space. Okay, space is okay, no problem. But no, my dimension tables are too big, I will divide further, so that I can also have a finer reporting. Yes, you can divide, but at that time, what is the advantage? Yes, you can do reporting at the similar whatever dimension you further divided, and of course you need to add join with whatever divided or new dimension you created out of it, so it will add more joins. Okay,
Sir,
so but yeah,
I will ask one question in Telugu. How to explain in English? I don't know.
yeah, tell me.
సార్ ఇప్పుడు మనం అంటే యాక్చువల్గా మన గవర్నమెంట్ సర్వే చేస్తుంది కదా సార్. సర్వే చేసినప్పుడు మనం టోటల్గా మనం ఇంటింటికి వెళ్ళి తీసుకున్న చార్ట్ అంతా కలిపి మనకి స్టార్ స్కీమ్ లైక్ దాన్ని మళ్ళీ వాళ్ళు ఏరియా వైజ్ సిటీ వైజ్ సెగ్రిగేట్ చేసేది దాన్నంతా మనం స్నోఫ్లెక్స్ స్కీమా కింద వస్తుంది అంతేనా సార్?
అవును, అంటే యాక్చువల్ అది మన సిటీకే కాబట్టి ఓకే, నీ టెర్మినాలజీలో యా మరి అంతే కదా. సో ఫస్ట్ కంట్రీ, దెన్ స్టేట్, దెన్ సిటీ. ఓకే, యా, సో యా
అంటే
యాక్చువల్ గా అది అంత స్నోఫ్లేక్.
అంటే సార్ మనం చేసి ఫస్ట్ ఏదైనా ఫస్ట్ గ్రౌండ్ వర్క్ చేస్తాం కాబట్టి కంపల్సరీ స్టార్ స్కీమా అనేది కూడా మనకు అవసరం.
A star schema, yeah, I mean what he's telling is everything will come out of star schema, right? In star schema only you're further dividing it, right?
Hmm.
Yes
Yeah.
or no?
Yes.
Yeah, so that's all. So initially, yes, it comes with star schema. Later on, if you want to further divide it, why you are further dividing? You are further dividing because you want to have a reporting at the granular level or at the next level you want to see, like state level or city level or village level you want to see. So you are further dividing. So similarly, initially you want to see at item level, but later on you want to see supplier level. So you want to split it as a different entity or different dimension. So you want to see at the different level, means supplier level. So you want to have another dimension. But let's say, no, I want to have at the item level only. Later on, no problem. I can write a query and get whatever done. It's okay. That's done. Actually, you don't need to split. But if you want to split, yes, you can split. That's why in the question, which is better, star scheme is better or Snowflake schema? Actually, there is a lot of, I mean, the data warehouse not come just today or tomorrow, yesterday, right? It is there since many years, like 30 years, 40 years, 50 years. If you go and search what is better, star is better or Snowflake is better, there is so many arguments, and they all decided that we should not say, they said, experts said, we should not say star is better or Snowflake is better. Everyone has their own, advantages. We should not say even this, there is no disadvantage. Everyone has their own advantages. Okay, in star means, yes, uh, there is redundancy, but with less joins you can directly join with fact table and get your data. Less joins means more performance you will have in star. Okay, in Snowflake schema, yes, you will be dividing further. So redundancy or reducing means data duplication you are reducing, but you have to join with the newly created dimension tables to get the final report. So more joins means sometimes your performance may be impacted. More joins means, but you will have a reduced storage, like that. But we should not say star is better or Snowflake is better. That is very, very important. I want to highlight in this class. Okay, so you can just type in Google which is better, star scheme is better, Snowflake scheme better. Nobody will say star is better or Snowflake is better. Everyone will say everyone has their own advantages. Okay, so and they will say that in case of Snowflake, yeah, we need to have more joins to get the data. But in case of star, yeah, you can directly join with fact, so you don't need more joins to get your data. Okay, but if in some entries they have lost, there is specific reason. In fact, I was asked this entry in this question. There is specific reason where customers will go exclusively for Snowflake schema. Snowflake schema. Then actually, you see, I was telling all these answers. Then you see, I mean, this happens maybe some 7 years or 8 years ago. Then I say, then he was not convinced with my answer. Then I asked him. I mean, at the end of the interview, generally I play this trick because I'm a trainer, right? If I don't know, I want to ask him only. Okay, tell me why people will go for stars. And then that interviewer said they want to report at the particular dimension. Then only, I mean, because some customers want to report at particular dimension, because here you said, right, item will be divided into supplier, so they want to do reporting at the supplier level. So for that they particularly want to create a separate dimension so that they can do, like, cubes reporting, slice and dice, like that he was telling. Okay, but anyway, I got that point, so I said okay. Okay, so finally at the point that he said is customer want to have a reporting at particular dimension, so that is the reason he is splitting this dimension into further. So because he want to do dimension, I mean reporting there, that's why they want to have a Snowflake schema like that. That is the interviewer who told me. Okay, so just be blindly believe me, like whatever I said. Most of the questions, if I don't know, I used to ask the interviewer itself because I want to hear from him what he is thinking. Okay, so that's what he said. Okay, I said okay, yeah, that's fine. But of course, I can also argue that, but you see, the same thing I can get it from the star schema. But yeah, that's not wrong. Yes, we can directly get from the star schema. But yeah, it's of course we should agree with him. We should not take him, argue with interviewer anytime. Yeah, what he said is also right. Yeah, if we want to have a separate dimension for a supplier type, yes, you can create so that you can do at the supplier level reporting. Yes, I just said okay. Yeah, thank you. Okay, yeah, that will help reporting at the, he was saying like cube and slice and dice. Yeah, slice and dice means you can report at the different levels. Okay, different levels in a 3D wise reporting. For that, that is the reason they will have a multiple dimensions. Yes, we should agree. Okay, yeah. Somnath, you got it right now. Somnath. Hello, can you hear me? Hello, can you hear me? Prasad, can you hear me?
Yes, sir. Yes, sir.
Yeah, you can hear me, right? Yeah.
Yes.
So now you got the like difference between star and snowflake. Okay,
Yes, sir.
why
Yes.
while there is a star, why people will go for snowflake and all.
Yes, sir.
Yeah. Okay. Some still connected or okay, fine. So yeah, that is about star and the snowflake schema. Okay, so I think yeah. So this one, in case of star schema, you will have less joins because you are not further dividing the dimension tables. So, but you will have more redundancy. So you will generally it will occupy more storage. You got it? These 3 points, Prasad?
Yes, sir.
Yeah, because only one table, all the data will be there, so more redundancy. So it obviously occupy more storage. In case of
Yes, sir.
Snowflake schema, you are dividing the dimension tables into further small dimension tables. So
Small dimension.
you will have more joins to get your data back. Okay, so you will have more joins. But since you are
Yes, sir.
dividing
Yes,
into
sir.
further dimensions, so you will have less storage
Yes,
due to
sir.
no redundancy. Clear?
Yes, sir.
Okay, cool. So yeah, okay. I think the next thing will be slowly changing dimensions because the dimension tables will tend to change over time. What are those dimension tables you see? For example, this item names will tend to change. Brands tend to, for example, you see once upon a time it's a Fair and Lovely, but now I think Fair and Lovely is coming in a different name. Okay, and brand, supplier, yeah, these things will tend to change over time. Okay, so since dimensions will tend to change over time, okay, for example, you say location you take, or for example, you take state. Okay, state names are also getting changed, right? That Andhra Pradesh is divided
Yes.
into Telangana and Telangana state it came.
Yes. Yes.
And similarly, you take, for example, take company name. Earlier it was, Tech Mahindra, I mean, something like Satyam Computers. Then it became initially they made it, I think Mahindra Satyam. Then they made it Tech Mahindra, like that, right? So dimensions means names. Even people names also will get changed over time, right? People names or email address or address will change over time, right? So that's why basically the dimensions will tend to change over time. Or for example, customer designation, initially he will join with some associate engineer. After 1 year he will become a like a software engineer, or after another 2 years he may become senior software engineer. So his designation will change, his salary will change, all these things will change. Sometimes his address also will change. So basically these dimensions will tend to change over time, so they are called slowly changing dimensions. Okay, So yeah, there are of 3 types: SCD type 1, SCD type 2, and SCD type 3. Professor, did you study them? I mean, like I asked
Yes,
yesterday.
yes.
Okay, you studied something about them?
Yeah, no, slowly changing dimensions, sir.
Yeah, you understood something?
Nothing, sir. I'm not searching for net.
Okay, no problem. Okay, we
Actually,
will cover them.
what is the current data means before 6 months data is
Yeah, yeah.
current data.
Anyway, I will. Yeah, I will tell them. Okay. I will tell them all these things. Okay. So in the next session, Somnath, are you there? I think he disconnected.
Yes, sir. Maybe.
Okay, cool. So anyway, now I will send all the 3 video links that we covered. Okay, in the email. Okay. So you just listen them once again. Okay, Prasad. Hello, Prasad. Can you hear me?
I can hear you, sir.